class. So this podcast has to do with mass-to-mass stoichiometry problems. If you saw an earlier podcast about stoichiometry, stoichiometry is simply using mole ratios to determine how much of one thing needs to react or is produced based on how much is reacted based on another compound's mass to begin with in the equation. Alright? So, with mass-to-mass stoichiometry problems, we're essentially going to start with mass of one thing, and we're just going to call that mass of A. Alright, and again, if you looked at the first stoichiometry, mole to mole are fairly straightforward and easy, but there's no scale in the world that measures moles for us. Scales always measure masses. Alright? So, we can go from mass of A to mole of A. And how do we do that? We do that using the molar mass. Alright? So this right here, we use molar mass. And where does the molar mass come from? It comes from the periodic table. Alright? So we can go from mass of A to mole of A using the periodic table. And then our next step is we're going to go from mole of A to mole of B. If you looked at the Intro to Stoichiometry podcast, this is essentially what that was. And this just uses mole ratios. Alright, so we have to have a balanced equation. And we're going to use our mole ratios to go from mole of one thing to mole of the other thing. And then lastly, usually moles doesn't help us much because if we find out how much we can make, who cares if it's a mole value, we want to know mass again. So we're going to go back to mass of B. And again, how do we go from moles to mass? Again, we use molar mass, which comes from the periodic table. Alright? So that is what a problem is going to look like. It looks very similar to what we did in our Intro to Stoichiometry, except instead of having just one fence post, we're going to have 3 fence posts because there are 3 separate calculations we need to do. Alright? So our equation for tonight's example is going to be this. If we react iron with oxygen, and we get, let's say, iron 3 oxide. So FeO, and it's iron 3, so we're going to put a little plus 3 up here. Oxide is always a minus 2, so its formula is really this. Alright, for me to balance this, irons, we can balance fairly easily, but my oxygen, notice I have a 2 and a 3. So how do I balance those? We balance them with the least common multiple. So I really need 3 oxygens and 2 iron 3 oxides. So if I put a 2 in front of my iron, I really have 4 irons, so our ratio is 4 to 3 to 2. Alright, so we might have a question like this. If 24.5 grams of iron are reacted, how many grams grams of Fe2O3 are formed or are produced or made. We'll say produced. Alright, so the problem starts with grams, and notice it ends with grams. We want to know grams, and we know grams to begin with. So we're just going to set up a fence and rail problem because we want to change our units from grams of iron to grams of Fe2O3. Okay, so we're just changing our unit. So we're going to start with what we know, and what we know is 24.5 grams of iron. It's extremely important. Make sure you put your unit, okay? Because with fence and rail, it is only as good as letting your units be your guide. So if you're not writing your units, you are dead in the water. Alright? So grams of iron is on the top left. We need to put grams of iron on the bottom right. And what is our first step? We go back up here to the top. We want to go from mass of A to mole of A. Alright? So my A is my compound or my element. So there's going to be iron up on top. And what's really the only thing that grams ever relate to? They can relate to moles. Alright? And if I have moles and grams in the same fence post, that is known as molar mass. When it's molar mass, we're talking about the periodic table. And if we're talking about the periodic table, how many moles is that? It is always 1. Alright, so 1 mole of iron weighs how much? Well, if we look on the periodic table, we're going to find that it's 55.845 grams of iron. That's how much 1 mole of iron weighs. Alright? So if we stop our math right now, we would have moles of iron. We don't want moles of iron, we want grams of iron 2, or iron 3 oxide. So our next fence post is going to be going from moles of iron, right, because I'm letting my units be my guide, And the second part is moles of A to moles of B. So moles of B in this case is Fe2O3. And I'm going from moles of one to moles of the other. And if I look up here at the top, how do I get this calculation? It's my mole ratio. So if I look at my balanced equation, and I want to see how many moles of, we'll just start with the Fe2O3 do I have? I have 2 moles of Fe2O3. And 2 moles of Fe2O3 are always equivalent to how many moles of iron? Well, I'm going to look at my iron, and it is 4. Alright? So, it is a 2 to 4 ratio. Right, and if I stop my math right now, I would have moles of iron 3 oxide, but I don't want moles of iron 3 oxide, I want grams of iron 3 oxide. So I'm going to do one more fence post. Moles is on top, so I want moles on bottom. And I want moles of Fe2O3. And what do I want to convert this to? I want to convert this to grams of Fe2O3. Again, if we have grams and mole in the same fence post, that's known as the molar mass. If it's the molar mass, we're talking about the periodic table. If we're talking about the periodic table, how many moles does it refer to? Always 1. So 1 mole of Fe2O3 weighs 159.687 grams. Alright, so if we look at units, we're going to cancel some stuff out here. I have grams of iron at my top left, I have grams of iron at my bottom right. I have moles of iron on the top left, I have moles of iron on the bottom right. I have moles of Fe2O3 on the top left, I have moles of Fe2O3 on the bottom right. So, if I get rid of all those things, what is left? What I have left is grams of Fe2O3, which is what I want. So the next thing I'm going to do is I'm going to multiply across the top. When I multiply across the top, I get 7,824.66 grams of Fe2O3. And when I multiply across the bottom, because I have no units, I just get a value, and that value is 223.38. Alright, now I just have to simplify that. When I simplify that, I get my final answer. My final answer is 35.0 grams of Fe2O3. Alright, and that is a mass-to-mass stoichiometry problem. Super easy. Start with what you know. Let your units be your guide. Mass of A to mole of A, mole of A to mole of B, mole of B to mass of B.